So if we did not do the 12.2 notes, here are the limit laws that I requested that you had written down somewhere. They are essential to continue.
Okay, so I don't know if I have those written down, but I have those written down. Does that make sense?
You have them maybe jumbled around,
Yeah,
just maybe not in one sequential
I have
order.
not written like that. That was really complicated. The way the first video guys wrote it down.
You like those better than this?
He like ends and minus ends and stuff.
Okay.
Yeah, because that's
As long as you understand.
okay. Anyway, continue.
That means you were watching the videos.
I like the first one better than the second.
Yeah,
Okay.
that one just really hurts my eyes.
There are other videos on YouTube. You don't have to use mine.
We don't want to learn the wrong way.
I don't.
There's no wrong way to learn. If there's a way to do it,
I don't want to be taught the wrong way. I can make a YouTube video and put it up. That's the wrong way.
it's not gonna get very many hits though.
That's why you're gonna do YouTube started.
Yeah. Okay, so everyone have these down?
Do they get paid for that?
If you reach a certain number of views, you get paid on YouTube. But you have to have a certain number of views and subscribers.
I can do it.
I could do it.
Is it like 1 million or something? A million? Is it like 500 or something?
I don't know how it breaks down.
Get the truth. So that's what our money's going to? That's pretty sad.
Alright, so these are also online. Alright, so you can copy them down. And we have a couple special limit laws. First of all, let me go over what they're saying real quick. So, this is saying if I'm trying to take a limit of a sum, I can break it up into limit of the first term and the limit of the second term, then add them together. Real simple. Same thing with difference, right? So limit of the first term minus limit of the second term. Real simple. Here, if I have a constant times a function, I can just pull the constant out, take the limit of the function, and then whatever that limit is, multiply it by the constant. Here, if I have a function f of x times a function g of x, I can take the limits separately, then multiply the limits together. Same thing with division. Right, so if I have limit of a function divided by another function, I can take the limits separately and then just divide the limits. Granted that limit of g of x is not equal to 0, right, because then we'd be undefined. And then exponent, same thing here. If I'm trying to take a limit of a function raised to an exponent, I can first take the limit, then raise it to the exponent. It seems pretty logical to me. And then here, if you're trying to take the limit of a square root or nth root of a function, you can take the limit and then take the nth root of that function. Okay, so I think they're pretty self-explanatory. Maybe they look a little complex, but when we go over some examples, hopefully they make sense.
Will we need to memorize all the limits?
I mean, I think these are self-explanatory once you use them, right? It's just saying you can break up. This is just basically letting you know you can do this. I mean, I think logically it makes sense you can do this, right? So take the limits individually, then add them together. It makes sense, right? So on the test, and you'll have multiple practice problems that you'll have you doing that. So I think it'll just be like, okay, I can do that.
Okay.
And then some special limits. If I'm taking limit of a number, like let's say I'm taking limit of 5. Right? It's not a function, it's not varying, so the limit is just 5, right? It's not going to change if I'm taking the limit of a constant number. Also, if I'm taking the limit of x and I'm approaching a constant a, it's just going to be whatever a is, right? Because I'm substituting a in for x. So if I'm taking just limit of a variable x, then the limit is just going to be whatever number I'm approaching, because I'm plugging that number in for x. Same thing here. Limit as x approaches a of x raised to some positive integer n, same thing. I can just plug in a for x, then take that number to a limit or exponent n, whatever n happens to be. Same thing with the square root. So I think they make sense logically. This is just showing you you're allowed to do that. Let's do some examples using our laws. So the first one, they want us to use our limit laws to find these 4 limits. First one being, limit as x approaches -2 of f of x plus 5 times g of x. So, using my sum limit law, I can break this up into limit f of x as x approaches -2, and then plus, and then, so I'm kind of using 2 here. I can pull the 5 out in front, so 5 times whatever g of x limit is. Okay, so I'm going to get my limit here, I'm going to get my limit here, multiply it by 5, then add my answers together. So, limit as f of x approaches -2. What limit am I approaching as x approaches -2 of f of x? That's the red graph.
1.
I'm approaching 1, right? From the negative side, I'm approaching 1. From the positive side, I'm approaching 1. So even though this is an open circle, I'm approaching 1 from both sides. If I'm approaching the same from the positive and the negative, then we're going to say my limit is 1. What is my g of x as I approach -2? So the blue line as x approaches -2.
-1.
-1. Right, so as x approaches -2 from the positive and the negative side, I'm coming to the same number, which is just -1. So that means I get 5 times -1. So 1 plus a -5, my answer is -4 for A.
Oh.
Make sense? B. Again, I'm going to use my limit laws. Right? So I'm allowed to take the limit of f of x, then multiply it by the limit of g of x. Then times limit of g of x as x approaches 1. So what is the limit of f of x as x approaches 1? Remember, that's the red line. 2. Right? So as x approaches 1, from the positive and the negative side, I'm approaching a value of 2. So I'm plugging 2 after there. What is what?
Represent a limit.
Limit g of x?
Okay.
I'm just rewriting this. Right here. Okay, and then I multiply that by whatever the limit of g of x is as x approaches 1. Well, what's the limit of g of x as x approaches 1? That's the blue.
It doesn't exist.
Does not exist. Right? Because from the negative side, I'm approaching -2. From the positive side, I'm approaching -1. I can't have a limit where my positive and negative side are different. So it does not exist. So you can't multiply 2 by does not exist, so our answer does not exist. Yes, sir.
Alright, so, I mean, my first, so like the red line, what exactly is that?
That's the f of x function. We don't know what the function is, we just know that whatever function f of x is, it gives us this red line.
So it's at least not a function, but they cross, does it pass the vertical line test, or?
It does pass the vertical line test. This is an open circle, this is the closed circle. So it's a piecewise function that's got 3 parts. Right, so it's got some part that's giving me this negative side, and it's leading up to -2, right? So less than, give me 1 second, and then I'll answer your question. Less than -2. Then it's got one part of the piecewise function that says when x is -2, y equals 2, period, it's just the point. And then it's got another part that says when x is greater than -2, I get this function. Okay, so it's got 3 parts to a piecewise
When you
function.
do that, can you like put the piecewise function with it, just like to help me understand, or?
I don't know that piecewise function.
Okay.
They just gave you a graph, they said answer some questions about it. Andrew.
Oh, can you explain what that dot is again? The random.
This random dot here, so it's a part of the piecewise function. It's saying when f of x equals -2, I just get the point 2.
Alright.
So whenever I plug -2 into my f of x function, whatever it is, I get the point y
So why
equals
is it
2.
not connected on the graph? I mean on the line.
Because it is simply just a point of a piecewise function. So, okay, so maybe, for instance, we got this big piecewise function, right, and we got f of x. I mean, I can't give you the curve because I don't know the curve, but maybe it's slightly curved, maybe, I don't know, -x squared when x is, it'd actually be -x squared. See, I'd have to move it, so it'd be -x. Plus squared and then plus 1. Right, that would give me an upside down parabola, moved 2 to the left, up 1, because we know our transformation rules. And then that's where x is less than negative 2. Right, not equal to because I got an open circle. Then the next part of the piecewise function is going to say it's equal to, it is actually equal to the number 2 when x equals negative 2.
Oh, yeah.
So when x equals negative 2, I just plug a 2 in. And then the other graph, I don't know what even to call that one, maybe like an x cubed. And then I'd have to do my shifts again. So maybe something like, and then this is not the function, so don't hold me to this. Maybe like, so it's going to have the same shifts, but this is when x is greater than negative 2. So something like that would give us this f of x function.
Or on the test and quiz, you make sure you have piecewise function.
On the tests and quizzes, there won't be graphs like this. You'll have to draw your own graph using the piecewise function, then answer questions about it. Okay, and that's on the LTA. So it's questions like that. Okay. So we've answered A and B. C. We got to do same thing. So I'll find the limit of f of x, then divide your answer by g of x. Okay. So what is the limit as f of x approaches 2?
1.5.
About 1.5? Okay. They're not asking you to be perfect because what happens as g of x approaches 2? 0. Right? So undefined. I can't divide.
Is there a difference in undefined and does not exist?
I was just going to bring that up. Thank you for bringing that up. There is a difference between does not exist and undefined. Because these limits do exist, but dividing the limits is undefined. So that's the difference. This limit does not even exist. Okay? So these have limits, but when I try to divide them, it's undefined.
So always like by dividing by 0.
Right, dividing by 0 would be undefined, yep.
But anything else make it undefined?
I can't think of a case where we'll come across that. Just if 0's in the denominator, it's undefined. And then part D says, okay, find the limit of f of x, then cube it, whatever it is. So you're allowed to pull that cube on the outside. And then once I find that limit, I cube it. So what is the limit of f of x as x approaches 1? 2. Right? So as x approaches 1, my function approaches 2. So I plug a 2 in, then cube it, and I get 8 for part D. Good stuff? Next, I'm just going to do one of these because I want to get through it quicker so you guys got some time. So first, I can break this up, right? So I can take limit 2x squared minus limit 3x plus limit 4. So
That's what it's telling you to do, right? By saying justify each step.
right. Well, it's saying, how am I allowed to do that? Well, that was my sum law, right? I'm allowed to break these up into 3 different limits. So now, limit as x approaches 5 of 2x squared. Well, I got my constant, I'd pull it out front, right? And then I would do my limit as x approaches 5. And I can just substitute that in. So I'm actually going to get So I'm actually going to get 2 times 5 squared, right? Because I'm just plugging my 5 in for x. Right? That was one of our special cases. right? Just goes right back to that. Same thing here. I'm going to pull the 3 out front, plug a 5 in for x. I'm pulling my constant out front. Okay, and then this one was another one of our special cases. If I'm taking the limit of just a number, it's just that number. And then solve. So 5 squared is 25 times 2 is 50. 15. So 50 minus 15 gives me 35 plus 4 is 39. Done. If you just plugged in 5, do you still get the same answer?
Yes.
Okay, in that case you get the same answer. And we'll get to direct substitution. It's the last problem. Sometimes it doesn't work. This case it would have gave you the same answer. Okay, next one. That looks like the same. Oh no, this one approaching 3 now. What's funky about this one?
Is this example 3?
This is the 3rd example, yes sir. So this one's giving you the same thing. Right, if you plug in the 3, you're going to end up with the same, you're going to end up with 16. You can check that. And then if you plug in your number here, what are we going to end up with?
Negative 4 over 3.
Negative 4 over 3. Okay? That's just plugging in. Okay, here, what if I plugged in a 1 right away? What would happen?
Undefined.
It'd be undefined, right? Because we'd have 1 squared is 1 minus 1. But what if I told you there was a limit at x equals 1, at x approaches 1? So, you believe me? Thank you.
Right?
No, we're approaching 1. So if we did what we just did and plugged in the 1 right away, we'd have a 0 on the bottom, so it'd be undefined. Right? But let's factor it first. Right, so x minus 1 obviously isn't going to factor in anything. But x squared minus 1, different to perfect squares. Different to perfect squares. Now, what can I do?
You can cancel it.
We are allowed to cancel those. So I get 1 over x plus 1. So now if I take the limit as x approaches 1, what am I going to get?
1/2.
1/2. So there is a limit as x approaches 1 of this function. But if you had just typed in 1 like you said to do in the last one, you would have gotten undefined. Alright. I got another one here where we can, let's see what we got next. Okay, so this one again, if we just plug 0 in, right, we get undefined. But I'm telling you there is a limit as h approaches 0. So simplify, you'll have some terms that cancel and you'll actually find a limit as h approaches 0. Okay, so you can do that on your own to check. Next, let's graph this piecewise function together because we're still having trouble graphing piecewise functions, and then we'll find the limit as x approaches 4. So first, let's graph the piecewise function. The first part says if x is greater than 4, so something's happening at 4. So that's always where we're going to start, right? They're saying something special about the number 4 with this function. So we're going to start at x equals 4. If I plug a 4 into my top part of my function, what am I going to get? Square root of 0 is just going to be 0, right? Okay, so if I plug a 4 in, I get y equals 0. So I get a open or closed circle at 4, 0.
Open.
Open, because there's no equal sign under our x is greater than 4. Okay, then what if I plugged in and it says greater than 4, so that means I'm going to have to plug in a 5 now. What if I plugged in a 5?
1.
I get 1, right? Because 5 minus 4 gives me 1. Square root of 1 is 1. Right, then if I plugged in a 6, I'm going to get 6 minus 4 is 2. So square root of 2 is like 1.1 something. So it's going to be just above there. So you can see this part of our function is kind of going like that. Now let's do the other part of our function where x is less than 4. So again, we're going to start by plugging x equals 4 into my bottom part of the piecewise function. And what do I get?
0.
I happen to get 0. Okay, so it's going to be, I'm just going to redraw it in orange to show you that they both have open circles at the point 4, 0. Now what if I start plugging values in less than 4? For example, let's start at 3. What value am I going to get?
2.
I would get 2. So at the point x equals 3, I get y equals 2. What happens next?
4.
Right, so if I plug a 2 in, I'm going to end up getting 4. So 2, right? And this is just a line with a y-intercept of 8 and a slope of -2. So I can just graph the line up 2 over 1. And I don't reach 8, but that's fine. So the left-hand part of that function is going like that. So do I have a limit as x approaches 4 of f of x? Do I have a limit as x approaches 4? Are my negative side and positive side approaching the same point as x approaches 4?
They are.
Yeah, they are. What point are we approaching?
0.
0. So the limit as x approaches 4 is 0. And that is the limit. That does not exist. That is not undefined. The limit is just 0, which is fine. We can have that. So the limit does exist and it's 0. We good? Kind of good with graph and piecewise functions. Kind of good with limits. Does today help us after yesterday scared us? A little bit? Okay. So I'll put the practice questions back up there. Tomorrow we have jackets.